Like many scientists of my era, we grew up in both rural as well as in urban areas. In my case, I had the opportunity to grow up in a village called Kampung Baru, Kampung Raja, near Petani Kedah. And it was that environment that gave me the interest in nature. And of course, later on in my life, the word biodiversity came into being. I was not very good performer in school, was maybe average or even below average. But I got my informal education through participating in every possible sports in the school, football, even boxing, although I was as thin as a scarecrow, baseball, badminton. And then I enjoyed things like poetry, drama, joined the dramatic society, debating society. The point that I like to make here is you should start with a broad-based education. You should understand not only the science, arts, but you should understand recreation, sports, and even a little bit of family life at the early stage. And of course, I had all those opportunities because I come from a family of 12 children. So you can imagine, in those days, one mother can look after 12 children without having to really get all stirred up because we had to be disciplined. So what happened is that the environment teaches us a lot of things, or force or put pressure on us to do things that are quite innovative. For example, we weave our own ropes from coconut husk by soaking the coconut husk in water and then beating the coconut husk and taking the strands one by one, tie it around the toes and then twisting the strands until they become a rope. So we make little baskets with the veins of the coconut leaves and things like that. And those are things I think that add up to what makes people maybe become inquisitive and scientific later on in their life. And it is an important ingredient is curiosity. You must have that curiosity early in life to ask yourself why, what, and when, or how of everything. Now, I look at the world from many perspectives, simply because I had the opportunity to be influenced by this environment. I school in Kedah, and then in Penang, which is then an advanced state. Then I went to college in Pakistan, which is a different environment. In those days, the Taliban were very friendly people. They were just ordinary people around the borders. I was in UK, in England, London, a different environment. I practiced as a veterinary surgeon in England. Again, I had the chance of a different environment. I was exposed to another higher education in Australia. Again, a different type of environment. And also a little bit of exposure in the American University, Stanford University, for a different type of course. But to come back to science and technology, as children in those days, we never had any guidance for anybody. We never knew what we wanted to be. In fact, we were we became what we became rather accidentally, probably, because nobody tells us that we should be doctors or lawyers. Maybe some families do, but the majority don't. So and then the opportunities of going to university is very limited. Today you have so many universities. During my time there was only University of Malaya. So a lot of us went to India, Pakistan. Otherwise we will never had a chance to get education. I did research initially at the village level in animal parasites, animal diseases. And when I was in Terengganu, there was no laboratory. So I converted a garage into a laboratory. Then I studied parasites of poultry, of cattle, of sheep, of goat. I produced a little book on lice and fleas. I innovated an inverted microscope with a camera attached to it to take photographs, so that my parasites are fully illustrated with photographs. And that's why I was able to produce an illustrated guide to these lice and fleas for domestic animals and humans in Malaysia. So the point I would like to make about this innovating a garage into a laboratory is, the most important laboratory is up here, up in the skull, in the brain. And the apparatus and the sensors that you put into a laboratory are your own 5 senses. Your hands, your nose, your eyes, your mouth, your ears are senses that can analyze. So the concept of research must be carried in sophisticated laboratories, I cannot accept. So I cannot accept somebody who says I cannot do any research because I don't have microarray, machines and what they call atomic spectrophotometer or whatever it is nowadays that you have. You can start off with this wonderful laboratory that you carry inside your cranium and use all the very sophisticated sensors that God has given us. But of course, people will say those will be very basic and mundane research. But it is the past mixed with the present. You put them into the blender that creates the future. And innovation is not a single idea. Innovation is many ideas put into an idea. And that's how you innovate. So if you look at a computer, you just imagine the components of the computer, how they have been innovated from. Somebody has to innovate the first wire, copper wire. Somebody has to innovate glass or plastic. Somebody has to innovate silicon chip. Somebody has to innovate the keyboard. So it's so many innovations to produce one innovation or one instrument. Thus comes to the point now. In my life, when I went through science, I studied viruses, which are which are invisible to the human eye. So we use transmission electron microscope, and we look at viruses. But my study was for a purpose. It's not just to look at viruses. These viruses, some of them were causing diseases and killing chickens. So in Australia, you are not allowed to bring in vaccines from outside of Australia. You're not allowed to bring viruses outside of Australia or any living organism. So therefore, I was tasked with the job of isolating this virus in Australia. So there were a few universities trying it. It was like a competition between universities to see who get this virus out first. So I managed to get it out first. And I also managed to produce what you call experimental vaccine against the disease. Now, one of the sad things about scientists in Malaysia is we are trained in a particular field. We get our PhDs, but when we come back, we are put in a position which actually wastes the training that we've had. So, of course, my training was not wasted initially, because when I came back with my doctorate, I was asked to help establish the University of Agriculture, the Faculty of Veterinary Science. So I was given the post of the head of Department of Pathology and Microbiology. So I began to establish and recruit staff, design laboratories, buy equipment, set the curriculum, and start off the first veterinary school under the leadership at the time of Tan Sri Professor Omar Abdul Rahman, who was our first science advisor. So I was his second lieutenant, so to say. But I was also given the task to set up the Fisheries and Marine Science faculty, which at that time was called a division. And of course, I also had the pleasure of serving as a master or warden of the colleges. And that gives me a lot of exposure with very young people about their wants in their everyday wants in the hostel, about how to satisfy the Kelantanis, the Pahang students, the Sarawak students, the Sabah student with the kind of food. So it became quite an interesting management issue of becoming a warden to make them happy. Now, later in life, of course, I was appointed in government service to become the Director General, and of course, that was where I focused on modernization of the animal industry in Malaysia. And that's where I established institutes and concepts of breeding using computer software programs to breed animals in a scientific manner. I established a few new things. One was the Institute of Biotechnology, Animal Biotechnology in Jerantut, to do embryo transfer, embryo splitting, embryo sexing. Then I established another institute called the Veterinary Management Institute in Cheras. My idea was, when I look at Intan was training managers for the PTD. So I said, what about training managers in the technical field? So I established a veterinary management training center in Rand. And of course, to the industry itself, I encourage the modernization of the poultry farms, especially the broilers and layer farms, to adopt automation, automatic drinkers, automatic feeders, and so on and so forth. And later in life, I relived my childhood days as a person whose love for nature was very strong. Then I had a few friends who shared this passion to be with nature, this time to actually spend time in nature. So I bought a 4-wheel drive, I equipped it with all the gadgets to go into the jungle, and almost 5 to 10 times a year I'm in the jungle, somewhere in Ulu Terengganu, Ulu Pahang, Ulu Kelantan, looking at nature, photographing nature, recording nature, watching nature. Not to study, not to produce any papers or anything of the sort, but just to really enjoy myself and with my friend. But But as a consequence of that, we learn a few things. And today there's a science called biomimicry. And this science of biomimicry, which I actually, earlier before the word biomimicry, I used a word called natural technology. Technology from nature in one of my books called Glimpses of the Environment. And then this lady by the name of Jean Bionus. So this lady by the name of Jean Bionus, she popularized biomimicry. In fact, she's now much seek throughout the world to talk about biomimicry. But it simply means to be inspired by nature, to mimic nature and be inspired by nature, because there are a lot of solutions already there. There are a lot of technology that's already there in nature, in terms of design, in terms of structure, in terms of materials, in terms of processes. They're already there. To go, give you a few examples. For example, the fins of a whale has got bumps on its fin, and we think that because it has bumps, it might be resisting water and it may not be efficient, but when they put it into scientific tests, they find that it is more efficient to be used on, say, aeroplane wings or blades of wind turbines and so on and so forth. And of course, if you are looking at designs, nature can provide you millions of designs. New materials, of course, nature can provide you. Look at the spider web. I think it's quite common knowledge that the spider web is 10 or 15 times, I can't remember, stronger than steel, diameter for diameter, of course. So I begin to enjoy nature, but at the same time I begin to equip myself with a bit of knowledge on biodiversity. And biodiversity is about everything, actually. About everything that we know is biodiversity. Because it consists of both living and non-living material, which means everything. But the important thing about biodiversity, which I sketch, is to show the interconnectivity. Nothing is independent. Everything is dependent on something. And something is dependent on something, and it goes off. And this is why we have biodiversity, to make life possible. But one of the things that puzzles me until today is I can't understand what is the role of humans in biodiversity. What is our role on Earth in terms of the processes that goes on to the world? I can understand the role of a fungus for breaking down organic material and pushing it back. I can understand the role of mouse deer that provides food for maybe the tiger, and and it has a link with plants because it will eat certain plants, and then carry the seeds to other parts of the jungle to propagate. But I can't understand until today what is the role of us humans in the ecosystem. So there's a lot to learn yet, to unravel the mysteries of nature. And I hope for a message to the youth in terms of biodiversity. Get inspired by nature and look at nature for some of the answers and make the innovations a sustainable innovation. An innovation to me should have significant positive impact. If an innovation does not have a significant positive impact, then it will have it could have a significant negative impact.